On these two examples, we're going to look at how to determine the value of k given the value of the roots. So we're working through question 2 and question 5. In the first one, question 2, we are given that x squared is equal to 2kx minus 9, and we are asked to determine the value or values of k if the roots of this equation are equal. So in order to do this, we first need to get this equation into standard form. So taking everything across the equal sign, we are going to end up then with x squared minus 2kx plus 9 equals 0. From here, I'm now able to work out delta. So remember that delta is equal to b squared minus 4ac. Substituting in my b value, my a value, and c value, I get the following. Negative 2k squared minus 4 times 1 times 9. Squaring the negative 2k, we get 4k squared. And then negative 4 times 9 will give me negative 36. But they tell me that the roots are equal. So therefore, delta must be equal to 0. Solving for k then, we have 4k squared minus 36 has to equal 0. Dividing through by 4, we end up with k squared minus 9 is equal to 0. Factorizing this, which is the difference of two squares, so we have k minus 3, k plus 3 is equal to 0. So therefore, k is equal to 3, or k is equal to negative 3. In question 5.1, we are asked to show that the roots of the following equation, x squared plus 2x plus brackets p plus 1 plus 2p plus 1 equals 0, are rational for all rational values of p. And we need to give reasons for our answer. So if we have a look at this question over here, again we are going to need to find delta, b squared minus 4ac. In this example, a is 1, b is the coefficient of the x, so it's going to then include 2 and the bracket p plus 1, and my c value then will be 2p plus 1. Substituting that into delta, we're going to get 2p plus 1 all squared minus 4 times 1 times 2p plus 1. In order to work this out, we're going to square the 2, so it will give us a 4. And we left then with p plus 1 all squared minus 8p minus 4. I'm going to need to FOIL the p plus 1 first. So foiling that, we've got p squared plus 2p plus 1 minus 8p minus 4. Multiplying the 4 in, I'm then left with 4p squared plus 8p plus 4 minus 8p minus 4. Adding and subtracting all the like terms, we left with 4p squared as my value for delta. However, we're not finished because the question asked us to prove that the roots are rational. However, we are not finished because the question asked us to show that the roots are rational for all rational values of p, and we needed to give a reason for this. So for roots to be rational, my delta value needs to be a perfect square. So we need to show that 4p squared is a perfect square. So if we were to have a look at it, we can say that delta would be the same then as 2p all squared. So therefore, the roots are rational. Question 5.2 reads as follows. For which value or values of k are the roots of kx squared plus x squared minus 3kx plus 2k equals 0 real and unequal? So having a look at this example, I have a problem because I have 2x squared. So in order to work with this, I need to take an x squared out as a common factor. When I do that, I now get my equation into standard form. So I have an a value then of k plus 1, a b value of negative 3k, and a c value of 2k. And I'm now able to find delta. So delta therefore is equal to my b value, negative 3k all squared, minus 4 times a, k plus 1, times my c value, 2k. Multiplying this all out, we're going to get 9k squared minus 8k. So I've multiplied the negative 4 and the 2k first, and I will then distribute it into the bracket. So we end up then with 9k squared minus 8k squared minus 8k. Adding and subtracting my like terms, I end up then with k squared minus 8k. We are asked to find the values where the roots are real and unequal. So to be real and unequal, my delta needs to be greater than 0. Taking this, I therefore have k squared minus 8k needs to be greater than 0. Factorizing, we have k minus 8 greater than 0. This is now a quadratic inequality. To solve a quadratic inequality, I then need my critical values. In this case, my critical values then are 0 for k equals 0 and positive 8. I will use a number line and a parabola to work out the inequality. So I'm going to put my critical values on my number line. And I'm going to draw my quadratic equation function or parabola. All right, I'm looking for where it is greater than 0. So to be greater than 0 would be this side, so everything less than 0. And on this side, anything greater than 8. So to write my answer, we would say then that k is less than 0 or k is greater than 8.